So I want to start with a kind of hypothetical, of course a phony hypothetical, but for me a kind of interesting hypothetical. Suppose we have been doing upstream technology analysis, or we're applying the precautionary principle to horseless carriage technology, I don't know, 1890, 1880, something like that. I want to make two observations. First of all, at that time, we didn't have a clue what was going to happen with cars. And then suppose we actually knew something, and you can look this up. In the US anyway, there have been something over 3 million car fatalities during the 20th century. The high point was in 1972 with 54,000 car fatalities. In 2007, 41,000. The good news is that there has been a steady decline in the number of fatalities per million miles driven, from something in the order of 20 some odd in 1921, the first year they collected that data, to 1.37 in 2007. So actually we've been getting better, but clearly cars are a dangerous new technology. What should we have thought about this? Should we have preempted them? And so when I think about this, and I think about the idea of doing upstream technology assessment of any sort, I get a little queasy. On the one hand, I was an early fan of doing this because it's a kind of article of faith for me that putting social scientists and humanists together with scientists and engineers has to somehow lead us to a better technological embedding in the social world. On the other hand, it just seems very hard to do this when we're talking about basically non-existent technology, when we know that we're bad at predicting how technologies will develop and how they will socially embed. I've been recently thinking about this because I've been interested in work on curing aging, as the phrase goes. And so we can start with a not that recent book now, Ray Kurzweil and Terry Grossman's fantastic Voyage, with the subtitle, Live Long Enough to Live Forever. They are not using that hyperbolically. They believe that we can, as they write, immortality is within our grasp. Although they note that we do not have all the techniques we need to indefinitely extend human life. But our paradigm shift rate, that would be the rate of technological progress, is doubling every decade. So the knowledge exists, if aggressively applied, for you to slow down the aging and disease processes to such a degree that you can be in good enough health and good spirits when the more radical life-extending and life-enhancing technologies become available. So basically the idea is live healthy now, make sure you're alive when we get these immortality accessing technologies in the future. This is sort of an interesting idea. I was reminded of an article I read many years ago when I was studying the recombinant DNA contretemps of the 1970s. Robert Sinsheimer wrote an article in Daedalus in which he claimed, he talked about 3 sciences or technologies, research areas that should not be pursued, one of which was on aging. He tells us that research on aging seems to me to exemplify the wrong research on the wrong problem in the wrong era. We need that talent elsewhere. More recently, however, Aubrey de Grey has written, this would be in 2004, but I think you'd find fairly similar remarks from him even more recently. However, we risk being responsible for the deaths of, count them, over 100,000 people every day that this technology, that would be anti-aging technology, is not developed. If we delay that progress by failing to speak and act to bring it about, to coin a phrase, I don't know much about ethics, but I know which risk I prefer to take. This sort of rather extreme ethical position has been questioned by Alfred Nordman in a moderately recent issue of Nanoethics. Nordman talks about what he calls the if and then syndrome. or a radical foreshortening of the conditional. And he writes, and it's worth thinking this through because this is important for my ultimate argument, the true and perfectly legitimate conditional, if we ever were in the position to conquer the natural aging process and become immortal, then we would face the question of whether withholding immortality is tantamount to murder. Becomes foreshortened too, if you call into question that biomedical research can bring about immortality within some relevant period of time, you are complicit with murder, no matter how remote the possibility that such research might succeed. We are morally obliged to support it. Nordman goes on to suggest that ethicists, in fact, have other things to do. We should not be focusing on the issues of immortality, which may or may not come in Ray Kurzweil's lifetime or anyone's lifetime, but there are some serious ethical issues that we actually should be attending to now. Rebecca Roach took Nordman to task in the next year of nanoethics, writing of what she called an unacceptable asymmetry. She argued, I think fairly persuasively to me, that scientists actually need to think sort of blue sky. They need to think about incredible futures. In part, that's how you break out of old paradigms, if you want to use that phrase. It's how you move research forward. In part, of course, you have to do a lot of very mundane work, but you also want to have some out-of-the-box kind of thinking. That makes some sense to me. But then, according to Nordman, ethicists can't be thinking about that. Ethicists have to be thinking about the here and now, so to say. So, in her words, provided that scientists are allowed free rein to speculate, whilst ethicists must confine their attention to current or emerging technology, it turns out that whereas scientists are bound only by their imaginations in choosing the ends at which they aim, ethicists are restricted to evaluating whichever of the scientists' projects turns out to be promising enough to warrant their consideration. This raises the risk of scientists squandering their time developing misguided solutions to ethical problems that they are ill-equipped to interpret and assess. In some sense, we have a kind of pair of squanderings. Do we want to squander the ethicist's time, or do we want to squander the scientist's time? And I suppose, to use a cost-benefit analysis of this, although I know that's been put into question, we would say perhaps ethicists are cheaper. So, you know, squander the ethicist's time. It won't cost you as much. So this is the kind of the problematic I've been trying to think through. And remarkably, Frederick Saudi enters my talk too. I thought to myself, my God, if a third person today mentions Frederick Saudi, I should just hang it up. Saudi wrote in a book, Science and Life, in 1920 about the possibility of what later became nuclear weapons or nuclear energy. He wrote, in fact, let us suppose that it became possible to extract the energy which now oozes out, so to speak, from radioactive material over a period of thousands of millions of years in as short a time as we pleased. From a pound weight of such substance, one could get about as much energy as would be obtained by burning 150 tons of coal. How splendid. Or a pound weight could be made to do the work of 150 tons of dynamite. Ah, there is the rub. 10 years later, Robert Millikan, in an article in Scribner's magazine, took Saudi to task. The article was called The Alleged Sins of Science. And Millikan writes about Saudi, saying, since Mr. Saudi raised the hobgoblin of dangerous quantities of available subatomic energy, science has brought to light good evidence that this particular hobgoblin, like most of the hobgoblins that crowd in on the mind of ignorance, was a myth. The new evidence, born of further scientific research, is to the effect that it is highly improbable that there is any appreciable amount of available subatomic energy to tap, alas. So let's bring this up to more contemporary issues. Just recently at the Oregon University of Health and Science, they have shown that they can do germline mitochondrial DNA therapy in monkeys. Roughly speaking, what this means is the defective DNA in monkeys can be replaced at the germline. So whatever was the DNA disease would be eliminated in that monkey and every other monkey that was produced, its produce, its issue, so to say. This sounds good. I mean, it's a kind of, you're not just curing the individual, you're curing all the individuals that that individual may reproduce. It is, however, of course, highly controversial. In a radio broadcast on NPR, this was about a week and a half ago, Arthur Caplan, noted bioethicist, said that it has been considered taboo. That would be germline therapy. If there are health risks, they will affect multiple generations. It could open the door to genetically engineering a lineage of people. So, while it sounds really good to essentially eliminate this DNA-borne disease forever and ever, it also opens up a whole series of other problems. I think it's significant to think through several differences in how different technologies sort of emerge and move forward in their social environment. And I want to focus on three issues before I conclude with a proposal. First is what I will call forewarned is forearmed. Nuclear technology, we had talked about it, but for the most part, we had not debated it in any seriousness. Millikan reassured us that this was not going to be possible. Yet, 15 years later, for most people, in an instant, we had a serious problem. The genie was out of the bottle, and we had to play catch-up with how to control, regulate, and not, as it were, mass annihilate ourselves with this new technology. By contrast, germline mitochondrial DNA therapy is emerging after approximately 30, 35 years of extensive discussion. Go back to Sinsheimer's article, which I quoted from, that's 1978. Sinsheimer refers to Saudi and Millikan because he believed that we would have a kind of recombinant DNA bomb. Well, that didn't happen exactly, but we've had a whole series of other kinds of issues that we have had to worry about as we've developed various kinds of recombinant DNA technologies, from Dolly the sheep some time ago to now the work at the Oregon University of Health and Science. And this is significant. It means that when this new research came out, it was possible for Arthur Caplan to simply put on a radio show the specter of eugenics. These arguments are already out there. Now, whether or not, in fact, we are going to control germline genetic therapy in a way that will be good or bad, I don't know. But I suggest that we are in a more powerful position to do so because we've had 30 years of talking about this kind of thing. We have ethical, legal concepts on the table to deploy as we try to think through what's the right way to go. So, forewarned is forearmed. This suggests, in a certain sense, that Rebecca Roach is right, Alfred Nordman is wrong. I'm sorry to say, Alfred. But that's only one consideration. Let me propose two more. Another is precision. There's been a whole lot of talk in the more science fiction-y end of nanotechnology, of various kinds of brain IT device interfaces, perhaps leading to some kind of a Borg. Indeed, Ray Kurzweil himself will talk about the third bridge to immortality, maybe some kind of a potential downloading of self into a more durable medium. This is not actually very precise in a scientific sense. We don't know how to do this stuff. On the other hand, we do know how to do certain kinds of translation of neural signals into actions for potential processes, or as we heard this morning, potential military applications. We have the experimental data with us now, and it's fairly precise. And precision here makes a difference. When you know exactly what you have to do, you can start making distinctions at a moral, ethical, and legal level that you can't make when you don't have that kind of precision. So precision seems to me extremely important. And this argues, it seems to me, the other way. It suggests that perhaps Nordman is right. It's just too early to do this if we don't have enough precision about what technology we're really talking about to give precision to our ethical and moral discussions. The last point I want to make is a point about time. So the painting on the left by John Penniman, this is a painting of Roxbury, Massachusetts. And for those of you who've been to Boston, it don't look like this anymore. Very pastoral scene, and it's a little hard to imagine anybody living in Roxbury, Massachusetts in 1791, when this was painted, looking at the freeway exchange and thinking, yeah, good thing. On the other hand, it's also very difficult to imagine anyone living today sort of imagining wiping out the freeways, throwing away the cars, going back to horseless carriage. We just couldn't imagine doing it. We have incorporated into our lives in ways that are, I would say, inextricable automotive transport. Now, yes, we could perhaps move towards better mass transit. There are various steps we can take, all of which have various step-by-step issues. But the point about this is, as we have moved from 1790 to 2009, our values have changed. And the fact that our values change means that the risks have changed because, as we know, risk is in part a matter of value. So if you're trying to measure risk at one time about some potentially future, yet to be realized technology, you can't measure it because you don't know what the values will be when the technology is actually there. This, again, I suggest, argues in favor of Nordman and against Roche. So I think these three things seem to me significant as you think through, well, how are you going to deal with this? So I want to close with a proposal that we make a distinction between what I will call reliable claims. For example, in 1930, was there specific scientific evidence for potential health risks from exposure to radiation? Yes, there was. Today, is there specific scientific evidence for potential health risks from exposure to certain nanomaterials? Yes, there is. It seems to me in these cases, our job actually is to sharpen our understanding, both scientifically and technologically. We will know better how these technologies will embed in their societies, and we should aim to close what I'll call ethical or normative questions. Our job should be to, as it were, wrap things up, make decisions about what's right and what's wrong in the sort of generic sense of those terms. Or to put it another way, our job should be to deliver a justifiable, normative product. That's for reliable claims. By contrast, with speculative, what I'll call speculative claims. So, for example, in 1930, is there specific scientific evidence for the rapid extraction of energy from radioactive materials? No. It was certainly seen to be a possibility. It wasn't a wild, totally science fiction fantasy. We knew the energy in some sense was there, but we had no clue how we could access that energy. And today, is there specific scientific evidence for the indefinite extension of life by any known means? No, there is not. We have, again, this is not radical, wild speculation. There is a lot of research on the aging process that is ongoing. We've made, actually, a fair amount of progress in understanding the aging process. Do we yet know how to control it? No, we're not even close. It, to my way of thinking, makes no sense then to aim at a normative product. It seems to me you have garbage in, garbage out. We simply don't know enough. You can say stuff and you can get a conclusion out, but it's not going to be a very valuable conclusion for a whole series of reasons, among them being by the time we get to indefinite life extension, if we ever get there, our values may have changed. It may have taken time. By the time we get there, the processes by which we might create indefinite life extension may be such that we will make certain distinctions about what's right and what's wrong about it that we can't even foresee now. So again, not worth doing that. On the other hand, it does seem to me that there is important ethical work left to do. Sort of specifically speaking, should we pursue this program, and how should we consider this? So, in the end, what I want to say is the job for what I'll call speculative claims, for blue sky technoscience, is not closing questions, answering them, giving us normative yeses or nos, but rather creating questions. We should examine, or perhaps to use more contemporary lingo, deconstruct assumptions regarding future certainties and desirabilities. Is aging a disease indeed? Is it a disease in need of a cure? We use that kind of language, yet the language is itself normatively loaded. Can we distinguish seeking a cure for cancer, or a specific cancer, from seeking a cure for aging, whatever that might mean, by thwarting each of the various causes of death? What are the roles that mortality plays in understanding human existence? And that's a very big question that could lead to dozens or hundreds of other kinds of questions. Does the rate of change in expected longevity matter? And of course, there's discussions about the fact that in the last century we have increased longevity from something like, 30 some odd years to 60 some odd years. And so it's no big deal if we just keep increasing longevity. But of course, rates matter, and in fact, the increase in longevity in the 20th century primarily due to infant mortality being fairly successfully dealt with, not with really changing the overall, as Sinsheimer put it, and many other people have, 70. So the main point here is we shouldn't be trying to answer questions. We really should be trying to ask questions, to open up more questions, or to put it in other terms, what we need is a normative process, not a normative product. We need to have a situation where people from multiple points of view on a specific future emerging, in some sense of the word emerging, technology can engage with each other in an open-ended dialogue about the issues that this emerging technology raises. And with that, thank you very much.